Have you ever wondered how a small cluster of clouds over the ocean can grow into one of the most powerful storms on Earth? Imagine looking out over the vast ocean and seeing only a cluster of clouds. Within just a few days, that same cluster can transform into one of the most powerful and destructive weather systems on Earth, a tropical cyclone. Every year, tropical cyclones threaten millions of people by bringing destructive winds, torrential rainfall, flooding, landslides, and storm surges. In the Philippines, these storms are among the country's most frequent natural hazards, making it essential for everyone to understand how they develop and why they become so powerful. At the end of this video, learners should be able to define a tropical cyclone and describe its main characteristics, identify the conditions necessary for formation of tropical cyclones, explain the stages and processes involved in tropical cyclone development, differentiate the classification of tropical cyclones based on PAGASA's maximum sustained wind speed, and lastly, recognize why the Philippines is highly vulnerable to tropical cyclones and the importance of weather monitoring and disaster preparedness. In 2013, Super Typhoon Haiyan, also known as Yolanda, became one of the strongest tropical cyclones ever recorded, causing widespread destruction across the Philippines and claiming thousands of lives. This tragedy highlights the importance of understanding how tropical cyclones form, how they are classified, and why following weather advisories and preparing for disasters can help save lives and reduce damage. A tropical cyclone is a large rotating low-pressure weather system that forms over warm tropical oceans. It is powered by heat and moisture from warm sea water, making it one of nature's most energetic storms. A tropical cyclone has three main stages. First is the formative stage or the origin, second is the mature stage, and lastly, third is dissipating stage. First is the formative stage or the beginning stage, where warm moist air rises over warm ocean water, allowing the storm to develop and begin rotating. Next is the mature stage, when the cyclone reaches its strongest intensity with a well-defined eye wall, and spiral rain bands. And then finally is the dissipating stage, where the storm weakens as it moves around land or cooler waters, gradually losing its energy until it dissipates. A mature tropical cyclone is composed of several important features. At its center is the eye, a relatively calm area with light winds and clear skies. In the eye is the eye wall, where the strongest winds and heaviest rainfall occur. Extending outward are spiral rain bands, which contain thunderstorms capable of producing intense rain, strong winds, and occasional tornadoes or waterspouts. Although these storms have different names around the world, they are the same type of weather system. In the western North Pacific, including the Philippines, they are called typhoons. In the Atlantic Ocean and Eastern Pacific, they are known as hurricanes. In the Indian Ocean and South Pacific, they are called cyclones. The only difference is the region where they form, not the storm itself. The formation of a tropical cyclone begins over warm tropical oceans. However, several atmospheric conditions must come together before a storm can develop. The first requirement is warm ocean water, with temperature of at least 26.5 degrees Celsius over large area. Warm ocean water provides the heat and moisture that fuels the storm. Warm moist air rises, cools and condenses into clouds, releasing heat that makes the air rise even faster. This lowers air pressure, causing more air to rush in. Because of the Coriolis effect, the air begins to spiral, forming a tropical cyclone. As long as it stays over warm water with favorable conditions and low wind shear, the cyclone continues to strengthen.
The Philippines is one of the countries most frequently affected by tropical cyclones because it lies within the western North Pacific Ocean, the most active tropical cyclone basin in the world. Now, on average, around 20 tropical cyclones enter the Philippine area of responsibility each year, with several making landfalls. These storms can cause flooding, landslide, storm surges, agricultural losses, infrastructural damage, and even loss of life. This is why weather forecasting, early warning system, and disaster preparedness are essential. Now that we have learned how tropical cyclones form and gain strength, the next question is, how do meteorologists determine how strong a tropical cyclone is? Now, to answer that question, they use a classification system based on the storm's maximum sustained wind speed. Now, in the Philippines, the PAGASA classified tropical cyclones according to their maximum sustainable wind speed near the center of the storm. Now, this classification helps meteorologists, emergency responders, and the public understand the storm's intensity and the possible hazards it could bring. Now, the first category is the tropical depression, with maximum sustained winds of 61 kilometers per hour or less. Although it is the weakest category, it can still bring heavy rainfall and cause flooding. Next is the tropical storm, with winds ranging from 62 to 88 kilometers per hour. At this stage, the stronger winds and heavier rains may begin affecting communities. If the storm continues to intensify, it becomes a severe tropical storm with winds between 89 and 117 kilometers per hour. This type of storm can cause moderate to significant damage, especially in areas exposed to strong winds. Once the maximum sustained winds reach 118 kilometers per hour, the system is classified as a typhoon. Typhoons can produce destructive winds, intense rainfall, flooding, landslides, and storm surge. Finally, when a typhoon reaches 185 kilometers per hour or higher, Pag-asa classifies it as a super typhoon. These are among the most powerful tropical cyclones and can cause catastrophic damage over large areas. Now, as you can see, as the wind speed increases, so does the potential for damage. By classifying tropical cyclones, meteorologists can better communicate the storm's intensity, allowing government agencies and the public to prepare and respond appropriately. To summarize, tropical cyclones are powerful rotating storms that develop over tropical oceans. They form when warm ocean waters provide energy, moist air rises and condenses, and Earth rotation causes the storm to spin. Now, as the storm intensifies, meteorologists classify it based on its maximum sustained wind speed. Understanding how tropical cyclone forms helps us better appreciate weather forecasting and reminds us of the importance of preparedness, especially in a country like the Philippines. And that's all. Thank you for watching.